In this video, we're going to talk about three different types of series: telescoping, geometric, and harmonic. So let's first start off with a telescoping series. So basically what a telescoping series is the following thing. So telescoping. Okay, so the telescoping series is just the summation from n goes from 1 to infinity of 1 over n minus 1 over n plus 1. Okay, so this is what we call a telescoping series. So basically what you're doing is that you're taking 1 over n and you're subtracting it to 1 over the following term. Okay, so what would actually be the answer? Is this going to diverge or is this going to converge? Well, one of the things that we can do, we can use the test for divergence. Okay, so the divergence test, which says all we gotta do is take the limit as n goes to infinity of 1 over n minus 1 over n plus 1. And you can see that when I put, or like if I plug in infinity in here, you're going to get 0 and 0. And what you're going to get is 0. Okay? Now, when the divergence tests say that it's 0, okay? So if it says that the divergence test is 0, then we don't know. If this is equal to 0, we don't know by using the divergence test. So actually here we don't know. Okay? IDK. So I'm not sure whether this converges or not. It may converge or may not converge. So what I'm going to do something different. So the divergence test didn't quite work. So I'm going to try to figure out what the sums should be. So what should S sub n be? Okay, well, let's go ahead and plug everything in. So let's plug in first n equals 1. So I'm going to plug in n equals 1. So I'm going to plug in 1 over 1 minus 1 over 1 plus 1. Okay, so plus. Now I'm going to write n equals 2. So I'm going to have 1 over 2 minus 1 over 2 plus 1. Then I'm going to add n equals 3. So that's going to be 1 over 3 minus 1 over 3 plus 1. And I'm going to continue this out, okay? And I'm going to go all the way to the n minus 1. So when n equals n minus 1, okay, you're going to have 1 over n minus 1 minus 1 over n. Okay, this is kind of weird to say, but I'm just going to write the n minus 1th term. And then when you equal n, so it's just going to be 1 over n minus 1 over n plus 1. Okay. All right, so let's say I was adding all these nth terms. So this is the n minus 1th term, and this is going to be the nth term. So I'm adding all of these guys. So what I'm going to have is 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus, then you have 1 over n minus 1 minus 1 over n plus 1 over n minus 1 over n plus 1. Okay? All right, now something magical is going to happen because you can see that if I drop the parentheses, I'm going to have 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5. You can kind of see the pattern already. Plus 1 over n minus 1 minus 1 over n plus 1 over n minus 1 over n plus 1. So you can see that all of the middle terms are actually going to cancel each other out. And all I'm left with is the first term and the last term. I'm going to be left with 1 minus 1 over n plus 1. So I have a formula for S sub n. And if you remember, if I want to be able to find the summation of this, all I got to take is to take the limit of this. So the limit as n goes to infinity of S sub n is just going to be the limit as n goes to infinity of 1 minus 1 over n plus 1. So when I put infinity here, this is going to go to 0, and I'm going to get 1. So what this says is the telescoping series summation from I goes from 1 to n of 1 over n minus 1 over n plus 1 is equal to 1 by telescoping series. Okay, so the telescoping series is going to be equal to 1. Okay, so could you possibly figure out what this is? So if I give you something that looks like this, the summation from I goes from 1 to n of 2 over n minus 2 over n plus 1. What is going to be that answer? Well, one thing that I can do is I can factor out a 2, summation from I goes from 1 to n of 1 over n minus 1 over n plus 1. We know that this thing by telescoping series goes to 1, so we have 2 times 1, which gives me 2. Okay, and this goes to 1 by telescoping series. Right? I'm just gonna write TS for telescoping series. Okay, so you're able to do this, and so if you can immediately identify a summation as a telescoping series, you don't need to be able to you don't need to do whoa, what happened to it? You don't need to be doing all of this stuff again. We've already proved it. You just know that the telescoping series is just going to go to 1. So it's one of the special types of series. Okay. Then we have something called geometric sequences in series. So we have geometric series. Okay. And what basically geometric sequences and series were, well, if you look at a sequence of geometric sequences, you have 2, 4, 8, 16, something like this. Or maybe like 4, 1/2, 1/4, something like that. Okay. Notice here that the pattern that you see is that you're consistently multiplying it by a factor of 2. Here you can see that what you're doing is you're multiplying it by a factor of 1/2 or dividing it by 2. Okay, so usually what we say for geometric sequences is that the nth term of a sequence is just a1 r raised to the power of n minus 1, where r is the common ratio. And the common ratio in this case is what is the factor that you're multiplying the first term to get to the next term. So in this case, the common ratio is going to be 2. In this case, the common ratio is going to be 1/2. Okay? So then we also have the partial sums, S sub n. There's also a formula, a1, 1 minus r to the n, divided by 1 minus r. And there's also one for infinite sequences, a1 over 1 minus r, as long as the absolute value of r is less than 1. Okay, so these are going to be really useful for you to kind of know. So make sure that you really do know these. Okay, these are ones that you really want to be able to do. Okay, so this means that you are able to figure out what exactly the sum will be using these formulas. Okay, you're not going to be able to do it all the time, but for the most part, you will be able to know using these particular formulas. Okay, so let me give you an example. Okay, so let's say you want to find the sum. Okay, so let's say you have the summation from from n goes from 1 to infinity of 7 to the power of 4, 7 over 4 to the power of n. Okay? All right, so notice that you want to be able to have it in this particular, in this particular form. You want to have it like this. Okay? One way to do it is you can take out, how can I have an n minus 1 there? Well, you can always write it like this. Summation from n goes from 1 to infinity. Pull out a 7/4 out. And then you're left with 7/4 to the n minus 1. Okay? So this is what you have. So now in this case, the common ratio, which is r, is going to be equal to whatever's in the inside. In this case, r equals 7 over 4. Okay? So if you want to find the partial sum, okay, S sub n, okay, so S sub n, notice that 7 over 4 is much larger than 1, so you cannot use this guy. You have to use the second one, okay? So I'm going to write down 2 different stars, okay? So I'm going to have S sub n is equal to A1. A1 in this case is this number, 7/4, 1 minus 7/4 to the power of n all over 1 minus 7/4. Okay, and notice that if I want to go ahead and figure out the sum, well, if I want to take the limit of this, okay, I'm going to take the limit as n goes to infinity, okay, of S sub n, you can see that this thing is going to go to infinity, because if I raise this number to a really, really high power, you're always going to get infinity, okay, always, 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 okay. So what you can say is that a geometric sequence or a geometric series will converge if the absolute value of r is less than 1, okay, and diverge if the absolute value of r is greater than 1. Okay? So if it's greater than 1, then it's going to diverge. In this case, because the value of r is 7 over 4, this is going to diverge. Yes, it's going to diverge. Okay? And the geometric series will converge if r is less than 1. If the geometric sequence or geometric series converges, then the sum is s sub infinity a1 over 1 minus r. Okay, so if you want to figure out what exactly is if I add these numbers, what exactly is it going to go to, this is the formula that you're going to use. Okay, so let's do a problem. Determine if the following converge or diverge. If it diverges, if it converges, find the sum. Okay? So let's say we want to find the summation from n goes from 1 to infinity of 4 1/2 to the power of n minus 1. Okay? All right, so in this case, notice that our r value, we can see that this is a geometric sequence. Okay, this part is a geometric sequence, okay, because it's in this particular form. Okay, it's in this form of the geometric sequence. Okay, so this series, we want to see if it's going to converge or not. Well, what is r in this case? A common ratio. R is 1/2, and 1/2 is less than 1. Since it's less than 1, it is going to converge. So we say that this thing is going to converge because by geometric series. Because we know this is a geometric series, we know that the middle part is going to be 1/2. Okay, that's going to be really small. So when I raise it to a really big power, it's just going to get really, really small. So it's going to converge to something. Okay, so how do we find the sum? So the way that we find the sum is using this formula. So s sub infinity is equal to a1 over 1 minus r. Okay, so what we're going to do, we're going to take a1, which is going to be 4, the number right in front of it, 1 minus 1/2. I put this in my calculator and I'm going to get 8. So that's going to be my sum. Okay. All right, now let's do this problem. The sum from n goes from 1 to infinity of 2 over n plus 4 over n divided by 7 over n to the power of n. Okay. So what is this going to be equal to? Well, one thing that you can do is you can break them up. So you can write it like this. Summation from n goes from 1 to infinity of 2n, 2 to the n over 7 to the n, plus the sum from n goes to 1 to infinity of 4 over n over 7 over n. So I basically broke up the summations. So now I can go ahead and factor out the powers. So the summation from n goes from 1 to infinity of 2 over 7 to the power of n, plus the summation from n goes from 1 to infinity, 4 over 7 to the power of n. Okay, so now I can pull out a 2 over 7 and a 4 over 7. So you're going to have 2 over 7 to the n minus 1, plus it's going to be 4 over 7 to the n minus 1. Okay, so notice that both of these guys are actually going to be geometric series. Here, r is equal to 2 over 7 because that's the number in front of in the parentheses. Here, r is equal to 4 over 7. Okay, since this is less than 1 and this is less than 1, both of them are going to converge. So these are going to converge. Now, what are they going to converge to? Well, let's go ahead and plug them into the formula. We know that it has to be a1 over 1 minus r. Well, this is going to be a1, which is 2 over 7, divided by 1 minus 2 over 7, plus this thing, which is going to be 4 over 7, divided by 1 minus 4 over 7. Okay, so let me bring out my calculator. So I'm going to have 2 over 7 divided by 1 minus 2 over 7 plus 4 over 7 divided by 1 minus 4 over 7. Okay, and what I get is 26 over 15. If you want to figure out what that is as a decimal, it's about 1.73. Okay, that's what basically it is. Okay, so sometimes you do have to manipulate these middle terms to be able to figure out or make it into a geometric series. So there's many different ways that you can do problems like that. They can be really complicated, but it's very, very easy to figure out. Now, the last thing right before we finish this video is just a harmonic series. Harmonic. And the harmonic series, basically what it is that the summation from n goes from 1 to infinity of 1 over n. What exactly is this? Well, if you think it's 0, it's actually not 0. This is actually divergent. So it diverges, okay? Why? Well, the test for divergence, if you see, is not going to work because it'll equal 0. And you know when it equals 0, it's not going to diverge or converge. So instead, what you want to be able to do is you want to be able to write down all of the terms. So when n equals 1 is 1, when n equals 2 is 1 over 2, when n equals 3 is 1 over 3, and so on and so forth. And what you will try to do is try to bound these things. So if you have 1 over 4, okay, well, if you look at these two terms, 1/3 and 1/4, these guys are always going to be greater than 1/2. Okay, because imagine this is 33%, this is 25%. If I add them together, that's more than 50%. Okay, so I know this is going to be 1/2. So if I plug in 1/2 for this, which is going to be smaller than that, notice that I'm adding a 1/2 plus another 1/2. Well, that's going to be another 1. So then this thing got bigger. So intuitively, if you do that for every single term, you'll see that it gets bigger and bigger and bigger at a slow rate. So basically, the harmonic series says that when you see this thing, this is just going to diverge. And if you see that, you just say by harmonic series. Okay? And that's basically all there is to it.